Good evening, ma'am. Welcome to the TNSET online.
Thank you, sir.
We
Shall I start the
welcome,
session?
yeah, all the participants for the day two session of PDE. So yesterday's session was really wonderful, ma'am. Our participants are really very say that very useful, and also they have learned many things from the yesterday's session.
Thank you so much, sir. If is there any feedback to improve this lecture, uh, I welcome the those type of feedback also, sir.
Yeah, yes, ma'am. We have received only one feedback. So our session is, if the session is little bit slow, so they
Okay,
are
sir.
we understand, ma'am.
I have to take little bit slower, sir, or
Yes, ma'am. If it is little bit slow, they have easily understand.
understand. They can understand. Okay, sir. Okay, sir.
Yeah, we can start the session.
Okay, sir. Okay. Good evening, one and all. Uh, uh, I welcome the second session of PDE. This is a simple linear PDE. So this question we have to find out the solution of this PDE. For finding the solution, they have given one initial condition also, that is u of x comma 0 equal to 6 into e power minus 3x. So this is PDE. This dependent variable u is depending on both the independent variable x and t. So u is a function of x as well as t. So yeah, already we have discussed in our last class the dependent variable which is depending on more than one variable, then we can say that that is a PDE. So here this is initial condition because here the time t is 0. So when the time is 0, then we have to say that is initial value. So therefore this is called a initial condition. So that this problem is called initial value problem, because this problem is solved with the help of the initial condition. Suppose if any problem solved with the help of boundary conditions, then that is called boundary value problem. Sometimes some problems have initial value as well as boundary value, because they are all need for finding the solution of the particular PDE. So now we are going to solve the solution. We are going to see the solution procedure of this partial differential equation. So here I am using variable separable method. So many of you um, may aware of this variable separable method. So this is a PDE. Already I have said there are two independent variables are involved. So first we have to take one assumption, that is the function of x and function of t into two separate terms for the solution u. So first we have to find out the derivative with respect to x, and then we have to find out the derivative with respect to t one by one. So first dou u by dou x, that is ux. Ux means this is partial derivative. So we have to differentiate this x term alone. So we have to keep this t term as a constant one. So x dash into t. Next we have to find out dou u by dou t. So ut, which is equal to t dash, because now we are differentiating with respect to t, therefore t dash This x term is a constant one. So ut equal to x t dash. Now we can substitute these ux and ut in the given equation. Then we get then we get ux means x dash t equal to 2 times of ut. Ut means x into, this is not a multiplication, this is x. So x into t dash plus, instead of u we can substitute this xt. So we get here xt. Next, this xt, we can take this xt to the left handed side. So x dash t minus xt equal to 2x t dash. So in these two equation we can take t as a common term. So the remaining term becomes x dash minus x into t equal to 2x t dash. The right hand side there is no change. Next, variable separable means we have to separate x terms in one side and t term in the another side. So here this is a x term, x dash minus x. Here one x is there. So this we have to take this x term to the left side. Okay. So we have to separate that this way only. So x dash minus x by 2x. Similarly, here t dash is there. So in the left hand side one t term is there. So we have to take this t into the right hand side. So t dash by t, and assume this ratio equal to k. Okay, so we can take this constant. Yeah, not only k, we can assume for any other constant. This is a simple constant, that is for equating purpose. So x dash minus x by 2x equal to k. Similarly, t dash by t equal to k. Cross multiply, then x dash minus x equal to 2x k. Then this equation becomes x dash minus x minus 2xk equal to 0. So in this two equation we can take x as a common term in the second and the third term. Then we get x dash x dash, I am writing here. So x dash minus x minus x. So if we take x as a common term, then the first term becomes 1 and the second term becomes 2k. So x dash minus x into 1 plus 2k. Then if we take this term in the right hand side, then x dash equal to 1 plus 2k into x. Then x day by x equal to 1 plus 2k. Now we can integrate this term. The left hand side is in the form of dx by x. So we know the formula for dx by x, the integration formula for dx by x, that is log x, isn't it? The same formula is used here. So x dash by x is log x. The right side term 1 plus 2k, it is a constant because 1, 2k are all constant. So 1 plus 2k into x, because here the independent variable is x. Under the x, capital X is a function of small x. So we are assuming like that only. Capital X is the function of small x. So log x equal to 1 plus 2k into x plus some integrating constant log c1. So here we can assume any type of integrating constant. Here log function is there, that's why I am adding the integrating constant also a log function, logarithmic constant. After that, if we take this log in one side, then log x minus log c1 we get log a minus log b. We know the formula for log a minus log b. This is the basic formula, isn't it? So log a minus log b means we get log of a by b. So log x minus log c1 means log of x by c1. After that, if we have to eliminate the logarithmic function, so taking exponential term on both sides, then e log, these two functions are inverse of each other, so they get cancelled, e log cancelled. So remaining we get x by c1, which is equal to e power 1 plus 2k into x. So x equal to c1 into e power 1 plus 2k into x. This is the solution for x. Next we have one more equation, that is t dash by t equal to k. Now we have to integrate this function. So the same thing, t dash by t equal to k means if we integrate, then t dash by t equal to log t. Similarly, the right handed side. So here now we are integrating with respect to t. So the k into t plus integrating constant log c2. Like the previous case, if we take the log c2 term into the left side, then log t by log t by c2 equal to kt. After eliminating the log function, we get a t by c2 equal to e power kt. Therefore, t equal to c2 into k, e power kt. So the first integration, so here this first integration with respect to x, in the second integration with respect to t. So we have to keep this thing in our mind. So now we are getting the solution for x and capital T. So now we can substitute into the assumed solution. So u of x comma t equal to x of x into t of t. This term only we are initially assumed. So x u of x comma t equal to x of x into t of t. Substitute into this equation, so we get for x of x, the solution is c1 e power 1 plus 2k into x, and for t c2 e power kt. Substitute those two terms, so c1 e power 1 plus 2k into x into c2 e power kt. So we get c1 c2 e power 1 plus 2k into x e power kt. Now we have to find out the integrating constant c1 and c2 value. So for this purpose, we are going to substitute the initial value. Already I have mentioned this is initial value because the time t value is 0. If time equal to 0, then we are usually saying that that is the initial value. So they have given in the question itself the initial condition u of x comma 0 equal to 6 e power minus 3x. Now we are using that condition. So substitute in this solution. So substitute t equal to 0 in the left hand side and the right hand side. So t equal to 0 means c1 c2, this term involving x, so there is no change in this term, so e power 1 plus 2k into x. But in the second term, so now we have one term t in the exponential term. So substitute t equal to 0, then 0 into k equal to 0, so e power 0 is 1. So we get c1 c2 e power 1 plus 2k into x, which is equal to 6 into e power minus 3x. So what will we get? So here the constant C1 and C2 equal to 6. So C1 and C2 equal to 6. And here the coefficient of x is minus 3. Here the coefficient of x is 1 plus 2k. So 1 plus 2k equal to minus 3. So the constant term can be equated. Similarly, the coefficient of x term can be equated separately. So C1, C2 equal to 6 and 1 plus 2k equal to minus 3. So 2k is minus 4 and k equal to minus 4 by 2 is minus 2. So substitute into this solution, then u of x comma t equal to substitute the values of C1 and C2 k in this star equation, then we get 6 e power 1 plus 2 minus 2 of x e power minus 2t. Instead of k, we are substituting minus 2. Instead of C1, C2, we are substituting 6. So this term is 2 2s are 4, so minus 4, minus 4, so this term is minus 4, minus 4 plus 1 is minus 3, so minus 3x. So 6 e power minus 3x into e power minus 2t. So we can simplify further. So here the base is same, so we can add the power. So e power minus 3x minus 2t. So minus sign is a common one, so minus of 3x plus 2t. This is our answer. We are getting this answer for that linear partial differential equation. So here this is a multiple choice question. So they have given 4 answers. So we have to choose the correct one among these 4. So we get not this one. Similarly, not this one. This is also not a correct answer. So this is a correct answer. So the answer is D, u equal to 6 e power minus 3x plus 2t. So simply we can solve this linear partial differential equation by method of variable separable. Here we are not using Lagrange's or any type of methods. Here we are using variable separable method. This type of questions will be asked in our set exam. Okay. Next, already in the first order PDE, in the last class, we have discussed about Lagrange's linear partial differential equation and its solution procedure. And for the nonlinear partial differential equation, we have discussed about Char-Pit method. Okay, that is a important method. Those two methods are like either Lagrange or Char-Pit method. Those two methods are very very important in the partial differential equation. Now we are going to discuss another important equation, that is Cauchy partial differential equation. This equation is coming under first order PDE. The solution procedure for this is a little bit difficult. Once you understand this concept, then you can easily solve this type of problem. So this is very very important topic also. So it is almost equal to Lagrange's. In Lagrange's, how can we solve that Lagrange's linear PDE? First we have to consider a partial differential equation. It should be linear. Linear means you may aware of the definition, that is the dependent variable and and its derivative should not be in product. That is called linear. Non-linear means the derivative and its dependent variable can be in product. So that is non-linear PDE. So for Lagrange's problem, only linear PDE can be solved. So that equation is of the form P P plus Q Q equal to R. So P small p is dou z by dou x, small p equal to dou z by dou x. Similarly, small q is dou z by dou y. So simple first order PDE. If z is a dependent variable. So under the auxiliary equation for this Lagrange's is dx by capital P equal to dy by capital Q and dz by capital R. So here z R term should be in the right handed side. If it is given the left handed side, first we have to take that R value into the right handed side. After that we have to write down the auxiliary equation. So the solution procedure for this Cauchy problem is almost similar to this Lagrange's problem, but a small variations can be made. That is, Cauchy problem basically depending upon the parametric equations. Here x, y are independent variable, z is a dependent variable. Okay, so first we have to find out the initial value for all those variables. So x naught, y naught, z naught. So these are all the independent initial independent values. After that we have to change that into the parametric equation in terms of t. Okay, if I explain one problem, then you can understand these concepts. So these are all first derivative. So derivative exists means it should be a continuous function, isn't it? So since differentiation implies continuous, the converse need not be true. So derivative exists means it must be continuous in some interval I. Uh, so if we consider a function f, that function involving x, y, z and zx and zy, isn't it? This is zx and zy. So these type of variables are involved. They are all continuous function in the region D. Now the initial value x naught, y naught belongs to the real number R, and pi of x naught, this pi of x naught, y naught equal to z naught. This equation will be given in the question itself. So if we consider a surface z equal to pi of x comma y, so this equation will be given in the question itself. So we have to take the initial value. That's why it is changed into z naught equal to pi of x naught, y naught. It should be passes through the curve C from x equal to x naught of t. So here x and x naught are same, but instead of x we are going to substitute in terms of t. Similarly, y equal to y naught of t, z equal to z naught of t, in which the direction ratios are normal pq minus 1, such that f of xy is at pq equal to 0. So this is some theory part. So we have to find out this curve is very important. So if we considering this is x, this is x, this is y, this is z. So x, y are independent variable, z is a dependent variable. If we consider a curve which is continuous in the z axis, then the image of this curve in the xy plane. Okay, this is the image. This let us assume this is a curve C. It is denoted as C or capital gamma we can in the problem they have given either C or gamma. That means the curve, the notation of curve. The image of this curve is uh, present in the xy plane. Okay, so these are the theory part. So if I am explaining one problem, then you can understood a little bit. Now I am concentrating more on this Cauchy problem because that is a important topic. So if you understand clearly, then you can easily attend a problem and get and score more full marks in that topic. So here the PDE is of the form P plus Q equal to R. So P may be X, Y, U. So here instead of Z, I am taking U. So P of X, Y, U, Q and R is also the function of X, Y, U with the initial curve gamma. Already I have mentioned they in the curve may be denoted by C or gamma. Gamma. So gamma from x naught comma y naught comma u naught. Okay, so this is this equation is of the form P plus Q equal to R. So the auxiliary equation is exactly equal to the auxiliary equation of Lagrange's equation. So small changes may be incorporated. Let us discuss here. Uh, so the auxiliary equation becomes, okay, we will discuss it later. So here we are going to discuss some important result for the different types of solutions. So here there are three types of solutions are exist. They are unique solution, infinite number of solutions, and no solution. Okay, let us discuss at which situation this type of solutions exist. So for this we have to find out this value. So P by dx naught by dt, Q by dy naught by dt, R by du naught by dt. So here P value, it can be obtained from the given equation capital P, capital Q, capital R. But what about dx naught by dt? So they have given one equation. From this equation we can take x naught value and in terms of t. Similarly y, similarly u. So we get x naught, y naught and u naught. After that we have to differentiate with respect to t those three functions. Then we obtained the value, the derivative values. So if the first two ratios are not equal, okay, the first two ratios are not equal, then the Cauchy problem has unique solution. These two ratios is not equal, these two ratios are not equal, then we get the unique solution. Okay, second result, if all the three ratios are equal, the first, what is the first condition? If the first two ratios are not equal, then the problem has unique solution. Okay, sometimes in the question they have asked about the solution type itself, but in the second case if all the ratios are equal, then we have infinite number of solutions, that is all the three ratios are equal. In the last case, first two ratios are equal, that is not equal to with the third ratio, then that Cauchy problem has no solution. Okay, so the first one is the first two ratios are not equal. If the first two ratios are not equal means, then we can say that the problem has unique solution. Suppose it is equal. Okay, suppose these two ratios are equal. Consider first ratio is 1, second ratio is 2, third ratio is 3. Then here I am briefly explaining, briefly conclude. So in the first case, if first ratio not equal to the second ratio, then we can say that unique solution. Unique solution means what is the meaning? Exactly one solution. Okay. Second case. What is the second case? Suppose the first ratio equal to the second ratio and these two equal to the third ratio, then the Cauchy problem has infinite number of solutions. It has infinite number of solutions. Suppose if the two ratios are equal, but these two ratio value is not equal to the third ratio, then we can say that the Cauchy problem has no solution. The Cauchy problem has no solution. This is the concept. Okay, if you now you can understand easily. Okay, we can go further. So the first in the first example you can understand a little bit because this is a simple problem. In the question itself they have given this is a Cauchy problem. Sometimes they may be given or may not be given, but most of the time they have mentioned it is a Cauchy problem. So the Cauchy problem 2ux plus 3uy equal to 5. So you can now easily identify it is of the form PP plus QQ equal to R, almost equal to Lagrange's linear equation. Okay, and if it is Lagrange's equation means this one equation is enough. Okay, this equation and this equation are no need, but in the Cauchy problem they have given these two equations. So from this given conditions you can understand this is not a Lagrange's, this is a Cauchy. Okay, so in the Cauchy problem they have given only this equation alone, they are not giving these two equations, but in the Cauchy problem they have given the extra they will give extra two equations. So now the question is we have to find out which type of solution exists for this problem, exactly one solution or exactly two solutions or infinitely many solutions or no solution. So we have to find out this thing. For this we have to check these ratios. Okay, so first we have to identify p value. What is p value? 2, isn't it? And what is q value? 3. What is r value? 5. Okay, so easily you can identify capital P, Q and R value. Okay, next is u. U value also given in the question itself. And the one more equation 3x minus 2y equal to 0. From this equation we have to find out x naught y naught value. So from this equation we can find x naught and y naught value. Okay, 1 minute. There is a network issue. Okay, yes. So from this equation, uh, P value is 2, Q value is 3 and R value is 5. And from this equation 3x minus 2y, we can write down 3x naught minus 2y naught. Okay. So here you have to listen carefully. So here instead of x, I am writing x naught, instead of y, I am writing y naught. So 3x naught minus 2y naught. For finding the parametric form, here we are assuming x naught equal to t. So x naught equal to t means substitute x naught equal to t here. So we get 3 into t minus 2y naught equal to 0. So if we substitute the x naught value as t, then we get the value of y naught in terms of. So what will we get? 2 y naught equal to 3t, then y naught equal to 3 by 2 into t. Now are you able to understand? From this equation 3x minus 2y equal to 0, we have to assume x naught equal to t and we get the value y naught in terms of t. So almost all x, the value x naught and y naught are in terms of t. Here there is no restriction for assuming x naught equal to t. We may assume y naught equal to t. Let us see what will happen. If we assume y naught equal to t, then substitute into this equation, then we get 3x naught equal to 3x naught minus 2t equal to 0. Then 3x naught equal to 2t and x naught equal to 2 by 3 into t. Okay. So if you assume y naught equal to t, then we get x naught equal to 2 by 3 into t. So in the final answer we get the same answer. So there is no restriction for assuming the value of t only x or only y. We can assume the initial I mean the parametric value t to any variable, either x or y. Okay. So next we have to find out the derivative. Okay, so that is the procedure, isn't it? First we get the value p, q and r. After that we have to find out the value of x naught, y naught, u naught from the given equation. After that we have to find out the derivative. This is the third step. So now we are going to find out the derivative. Okay, so the derivative here x naught equal to t. Then what about dx naught by dt? Dx naught by dt equal to 1. Similarly, y naught equal to 3 by 2 into t. So what about 3 y naught by dy naught by dt? That is 3 by 2. So here u equal to 1. It is given in the question itself. U equal to 1 is given in the question itself. So that is also assumed u naught equal to 1. Now I would like to mention here. So here, if x equal to x naught, y equal to y naught means z should be z naught. Moreover, z equal to pi of x comma y means z naught is pi of x naught y naught. So if we change the variable x and y into x naught and y naught, then the value of z is directly changed to z naught. Okay. So similarly, so instead of z, here we have u. So this u is immediately changed to u naught. So we get u naught equal to 1 because u is a function depending on x and y. So u naught is a function depending on x naught and y naught. So here the u naught value, u value is simply 1. Suppose this u is in terms of x and y, then we have, for example, if u is, let us consider u equal to some x plus 2y. Okay, just assume. Then change this x and y value in terms of t. Then what will we get? Then u naught is x naught. So instead of x naught, x naught plus 2y naught. So instead of x naught, we get t. Instead of y naught, we get 2 times of 3 by 2 into t. So we get 2 to get cancelled. So t plus 3t equal to 4t. Then this u naught value is also becomes in terms of t. This is an example, but in this case u is simply a constant, that is 1, so there is no problem. Therefore u naught equal to 1. Okay, then we have to find out the derivative. Then dx naught is dx naught by dt equal to 1, dy naught by dt equal to 3 by 2, du naught by dt. So here there is no t term, that is, therefore it is 0. Suppose if it is u naught equal to 4t, then du naught by dt becomes 4. Next we have to find out the first ratio. What about the first ratio? The first ratio is P by dx naught by dt. Second ratio Q by dy naught by dt. Third ratio R by du naught by dt. So first ratio d P by dx naught by dt. So what is the P value? P value is 2. 2 dx naught by dt is 1. So 2 by 1 is 2. And q value is 3, dy naught by dt is 3 by 2. So 3 get cancelled, so we get 2. Okay, otherwise we can write this term as 3 into, take reciprocal and then write in the product form. So 2 by 3, so 3 get cancelled, then the remaining we get 2. Okay, now you can easily see that uh, uh, P, the first ratio, okay, the first ratio and the second ratio equal. If the first ratio and the second ratio are not equal, if the first ratio and the second ratio are not equal, then we can say that okay, the first ratio and the second ratio are not equal, then we can say that it is has unique solution. But here the first ratio and the second ratio are equal. These two has the same value. So now we are going to check the third ratio, R by du naught by dt. R value is 5 and du naught by dt equal to 0, because that is a constant value. So if you differentiate, we get 0. So P by P, the first ratio and the second ratio are equal, but the third ratio are not equal. Then by the result, this is the definition for no solution. Okay, verify it once. The third result, P equal to Q and not equal to with the third, then we get no solution. Therefore, this Cauchy problem has no solution. So the correct option is P. So this problem has no solution. Okay, one more question. Okay, now I want to summarize this problem. First, from the given Lagrange's type equation, we have to find out the value of capital P, capital Q, and capital R. after find out the value of PQR, we have to find out the parametric equations. For that, from this equation, we can substitute either x equal to t or y equal to t, and then we get the remaining variable in terms of t, and substituting x and y value in u. Otherwise, if it is a constant term, we can take as it is. So all the three values x, y, u becomes x naught, y naught, u naught, and then these three values are in terms of t. After finding those values, we have to differentiate x naught, y naught, and u naught. Then we get the derivative dx naught by dt, dy naught by dt, and du naught by dt. After that, we have to find out the ratio p by dx naught by dt, q by dy naught by dt, r by du naught by dt. So, if the first two ratios are not equal, then we have a unique solution. If all the three ratios are equal, we get an infinite number of solutions. If the first two ratios are equal, but that is not equal to with the third one, then we get no solution. Okay. Now we will discuss the second problem. So here you can see that this is Lagrange type of equation. Lagrange type of equation ut plus ux equal to 1. So here the coefficient of ut and the coefficient of ux is p and q, and the right hand side value is r. So here t is greater than 0. The initial conditions are r and the u value are given in the single equation. Okay. Then can anyone guess what is the value of x? Can anyone guess? Yes, correct. The value of x is t square by 4. And what is the value of y? Y, that means not y not. So in from this equation, okay, if you understand properly, then you can easily guess the value of x naught in this equation. If you are following my uh, teaching, then you can easily say the answer. X naught is t square by 4 and y naught is t. Then what about the value of u naught? Yes, correct. T by 2. Okay, so x naught is t square by 4 because the first coordinate always x, the second coordinate is always y. And the third coordinate is sorry, not the third coordinate, and the value of the dependent variable u is u naught t by 2. So again we are going to check only one solution, two solution, and infinite number of solutions are none of which is differentiable on the characteristic base curve. Okay, let us discuss this question. Now you have some basic knowledge in this type of problems. First, we have to find out the value of PQR. P is U, Q is 1, and R is 1. Okay, so UUX plus UT equal to 1. So this is P value, this is Q value, this is R value. Next, from the initial condition, we can take the value of x naught, y naught, and u naught. Okay, x naught, y naught, and u naught. After finding the value of x naught, y naught, u naught, what we have to do? We have to differentiate. Then dx naught by dt. Okay, differentiate this equation t square. If you differentiate t square, we get 2t by 4. Then we if we simplify, then we get t by 2. Then differentiate the second one, dy naught by dt, that is if you differentiate t we get 1. Then differentiate the last term, du naught by dt, then 1 by 2. So these are all the derivatives. Now we have P equal to Q. In the first question, we didn't have like this because in the first problem, P, Q, R value all are constant. But in this problem, P value is in terms of U. I mean, P value is a variable, that is U. So for this U, we have to substitute this U in terms of U naught. I mean, in terms of the parametric form. So you have to understand one thing. Um, Once you write the parametric form, you have to change all the P, Q, R, X, X naught, Y naught, and U naught value into the parametric form. Okay, just to go through the ratio. So here you can see that this is P of X naught, Y naught, U naught, Q of X naught, Y naught, U naught. So we have to convert all those terms into the parametric form. Okay, so here the P value is in terms of U, so we have to write down the parametric form. So P equal to T by 2. So for this U value, we have to substitute here. Okay, then we have to find out the ratio. So capital P by dx naught by dt. What is capital P? T by 2. What is dx naught by dt? That is t by 2. So t by 2 get cancelled, the value becomes 1. Okay, second one. Q by dy naught by dt. What about Q? 1. Dy naught by dt 1. Therefore, this value becomes 1. So now we get the first ratio equal to the second ratio. Then okay. Now we have to check the third ratio. What about the third ratio? R by du naught by dt. Up 1 by 1 by 2, that means 2. So that is not equal to the third ratio. Then this has no solution. Okay. From the result we are getting the Cauchy problem has no solution. Okay. Now we have a look on the options. In the four options we have only one solution, two solutions, an infinite number of solutions, solution something. Okay. So by the problem we get no solution. Sorry, the PDE has no solution. So this is the result we are getting after solving this Cauchy problem. So no solution means, what is the meaning? Uh, Infinite number of solutions and only one solutions. Okay, let us discuss. So no solutions means these two are wrong. Uh, no unique solution. Yes, here no unique solution. Okay, I will check and give the correct sentence. So here the first and third one is wrong. So only one solution and infinite number of solutions is wrong. So A and C are wrong. Now we are going to find out, this equation has more than one answer. So next we have to find out the auxiliary equation. So dx by p The second variable is not y, that is q, t. So dt by q and d u by, this is du by r. Okay, because here we have x, y and u. Similarly here uh, uh, t and x are there. So dx by p, dt by q, du by r. Okay, so dx by u, because the value of p is u, and dt by q, the value of q is 1, and du by r, that is 1. Taking the first and last ratios, cross multiplying, we get dx equal to u into du. So x, after integrating, x equal to u square by 2 plus integrating constant c1. Therefore, we get x minus u square by 2, which is c1. Similarly, if we are considering the second and third ratio, we get a dy equal to du. After integrating, we get t equal to u plus c2. So t minus u equal to c2. Now we have to find out the relation between c1 and c2. So t equal to uh, let us consider t equal to s and u equal to s by 2, x equal to s square by 4, because in this relation, if we substitute t equal to s, listen here, if we substitute let us consider t equal to s, then what about the x naught value? S square by 4. Y naught value s, u naught value s by 2. Okay. So from this equation, we are getting t equal to s, u equal to s by 2, x equal to s square by 4. Okay. So here there is no y term, that is a dt term. So substitute in the first solution. What is the first solution? First solution is x minus u square by 2. That is x minus u square by 2 equal to c1. This is the first solution. Second solution is t minus u equal to c2. This is the second solution. Okay, then substitute x, then s square by 4 minus 1 by 2, u value s by 2 the whole square equal to c1. After simplifying s square by 4 minus s square by 8 equal to c1. In the second solution, t equal to s, u equal to s by 2, then s minus s by 2 is s by 2. So we get c2 equal to s by 2. Substitute c2 equal to s by 2 here, then we get s by 2 the whole square, therefore c2 square. Next to 1 by 2, c2 square means s square by 4, so c2 square. So c2 square minus half c2 square equal to half c2 square, which is equal to c1. So we have c2 square minus 2c1 equal to 0. So c2 square is t minus u. C2 square is t minus u, and c1 is x minus u square by 2. Substitute these two values here. So t minus u the whole square minus 2 into x minus u square by 2 equal to 0. After simplifying this, we get a quadratic equation in terms of t. Uh, After solving this quadratic equation, we have the u values. By using this formula, we get the u values u equal to t plus or minus square root of 4x minus t square by 2. There are two solutions we get. Therefore, option B is correct. And one more solution, option 4 is correct. If you differentiate dou u by dou x, if you differentiate this u with respect to x, then this term becomes 0. Then here 1 by 2, uh, then minus 1 by 2, 4x minus t square whole power minus 1 by 2 into 4. So then we get 2 by square root of 4x minus t square. When x tends to t square by 4, when x tends to t square by 4, 4 get cancelled, then t square minus t square equal to 0. Then we get this term becomes 2 by 0. Anything by 0 is infinity, therefore the derivative is not exist, therefore this function is not differentiable, therefore answer D is correct. So the correct answer is B and D. Okay, so there is no unique solution, therefore first option and the third options are wrong. There are two solutions for this Cauchy problem, therefore second option is correct. Moreover, this function is not differentiable, therefore fourth option is also correct. Okay, this is the same Cauchy problem, because if it is ut minus xux plus 1 minus u means this is Lagrange's linear PDE, but in addition to that they have given one more condition, therefore it is a Cauchy problem. So we have to find out the solution of this problem. So from this we have to find out the p, q and r value. So p is in terms of x and r is in terms of u minus 1. So you should you have to remember, we have to find out the parametric relation for p and r also. Q, here q is a constant, so there is no worry about q. Next we have to find out x x bar. Here we are considering the auxiliary equation. We get dx by p, dt by q, and du by u, du by r. Then minus x1 and u minus 1. After integrating, we get t equal to log of c1 by 1 minus u. Then after simplifying, we get 1 minus u into e power t equal to c1. Similarly, in the second ratio, we are for the second solution we are considering the first and second. Therefore, dt by minus x equal to dt. After integrating, we get minus log x equal to t minus log c2. After simplifying, we get x e power t equal to c2. Already we have discussed the general solution can be written as either pi of u comma v equal to 0, or u equal to pi of v, or v equal to pi of v u, isn't it? So, so u is here the first solution 1 minus u into e power t, pi of the second solution x e power t. The given condition is u of x comma 0 equal to g of x. That means we have to substitute t equal to 0. Then what will we get? T equal to 0 means 1 minus u of x comma 0, because u is u of x comma 0, isn't it? E power 0 is 1. Here 1 minus g of x, which is equal to pi of x, because here e power 0 is 1. So if we subtract by 1, we get 1 minus u of x, here 1 minus g of x. So this 1 minus u is pi, so 1 minus g is pi, then replace x by x e power t, then we get pi of x e power t. This pi of x e power t, we can substitute 1 minus u into e power t, then we get 1 minus u equal to e power minus t, because 1 minus u, take this e power t into the left hand side, then it becomes e power minus t, then 1 minus g of x e power t e power minus t. So the answer is the first option. Answer is the first option. U of x comma t equal to 1 minus e power minus t, 1 minus g of x e power t. Okay, this is the a big problem in the Cauchy type of questions. We will discuss this problem in the next class. In the next class, we will discuss the classification of PDE and the solution procedure for higher order PDE. Okay, this is the Cauchy problem. This is an important one. So we will discuss in the next class. and the classification of PDE will be discussed in the next class. Higher order partial differential equation, the solution procedure for that. And the last topic is variable separable method for higher order PDE, wave equation, heat equation, and Laplace equation. We will discuss one by one further. Okay, thank you.
Thank you, ma'am. It was really wonderful session, ma'am. Really, you have covered many topics today. So, and also discussed about the question problems that is very useful for all the aspirants who is preparing the TNSET for 2024. Really, thank you, ma'am, for
Thank you
your
so much, sir.
timing. Thank you, ma'am.
Thank you, sir. Thank you so much.